Hello and welcome, Mr. Lyons here. Hope all is well. And today we're talking about scientific notation, and that's just how you write really, really, really big numbers and really, really, really tiny numbers, right? We're on page 67 here, writing numbers in scientific notation and standard form. We know what standard form looks like, right? Like 5, 10, 15, 20, 50, 60. But scientific notation is something new, and it's used to express incredibly, you know what that word incredible means, incredibly small and incredibly large quantities, right? If you have a second, pause and Google how many cells you have in your body, right? You have 30 trillion cells. That's 30 trillion, whoop. What is that? Million? What is that? Billion? Is this trillion? Thousands? Millions? Billions? Trillions? Yes. This is how many little itty bitty cells you have in your body. And when you're talking about science and you're dealing with these very large numbers, you don't want to continue to write this out, right? So we have a new way, a scientific way of writing large numbers, right? And then if you think about how big a millimeter is, right? Millimeters are short, really tiny. And if you think about the size of a single cell, right? A cell is not wide, it's not big, it's not thick at all, right? If a millimeter is this big, right? If you cut half of a millimeter, right? That's 1/2 of a millimeter. But if you talk about the size of a red blood cell in your body, right? It's super, super tiny. Like it's 0.00 what? 65, 60, what is that? A hundred thousands, 10,000, hundred. It's like 65 hundred thousandths of a millimeter. That's tiny. Can you imagine like if this is half, what if you cut this little piece into 100,000 pieces, right? That's how big a red blood cell is, right? So we're using scientific notation to talk about really small and really large numbers. And there's a really specific way of writing this down. So this is scientific notation. You'll notice we have two factors here, right? Two factors, right? This first factor is what we call a leading factor. And it's simply called a leading factor. Why? Because it's literally just leading. Like it's out in front. It's the leading factor here, right? It's the leading factor. And we call this, what's this other factor? This is, 10 to the third, 10 to the fourth, 10 to the fifth. It's a power of what? We call these powers of 10, right? 10 to the first, 10 to the second, 10 to the 10th, 10 to any power, 10 to the x power, right? 10 to any power is called a power of 10. This is how you write scientific notation. You have a leading factor and you have a power of 10. Look at these examples here. What do you notice about all the leading factors? Yeah, some of them have decimals, but all the leading factors are greater than what and less than what? What do you notice? Take a look at the leading factors in example 1, 2, 3. All of them are at least greater than what? That's right, they're all at least greater than 1, but none of them go past 10. And that makes sense because our second factor is a power of 10, your leading factor is going to be at least in between 1 and 10. It's not going to go past 10 because that means you can fit another 10 in here, right? So our leading factors is a very important piece. Our leading factors are between have to be greater than 1, but they have to be less than what number? They have to be less than 10, right? Because if they're bigger than 10, then you can fit another 10 in there, right? And if they're less than 10, then you can take away another 10, and we'll see what that looks like. But in scientific notation, you have a leading factor, and you have a power of 10 here, okay? So let's take a look. We're writing these scientific notations into standard form. Let's take a look here, right? You have 8 times 10 to the third power. That's how you say that. What's your leading factor here? Go ahead and circle it. 8. What is your power of 10 here? Go ahead and put a square around it, all right? It's your power of 10. All right, this is in scientific notation because our leading factor is in between 1 and 10, and we have a power of 10 here. Is this number going to get bigger or get smaller? Think about what we did on the previous page. That's right. This number is actually going to get bigger. This 8's going to get bigger. by how many decimal places? Because in the past, we used to think you just add a zero. No, you're actually increasing the number of decimal places that you have here. So let's make it look like money, right? Whenever I deal with decimals, I like to make it look like money, right? That's what 8 looks like. But it's being raised to 10 to the third power. So how many place values? How many place values are you going to get? This is saying you're going to gain 1, 2, 3 place values, right? And I'm going to put a 0 right here. Right? 0 in the empty space. Now what number do you have? And you can even check this on Google or on your calculator. All calculators should have this little triangle symbol right here, this little caret piece. And I think you hold Shift and 6 on your computer. Shift 6 on your computer to add a caret there when you're doing math if you want to use Google as a calculator, right? 8 times 10 to the, use your little caret symbol. You should have that on your calculator as well, to the third power. And then you hit enter, and look at what we got, 8,000. It's always nice to have a calculator on the side, but what we're doing today is so you won't need to use a calculator, right? 8 times 10 to the third power. You gained 1, 2, 3 decimal places, which gave you 8,000, right? We did this on the previous page. Take a look at example 2 here. Take a look at example 2 here, right? 7.42, what's my leading factor? 7.42. What's my power of 10? 10 to the 5th power. Is this number going to get bigger or get smaller, and how can you tell? That's right. This number is going to get larger because we're multiplying by 10 to the 5th power, right? You got a positive exponent here. That's 7.42. I like to write that out. And we're gaining. This number is going to get bigger, so we're moving our decimal place to the right or to the left? To the right, 1, 2, 3, 4, 5, 10 to the 5th power. We gained 5 place values here. And so I'm just going to rewrite my number. I like to put my commas in at the end. 1, 2, 3, hook it, right? Ones, tens, hundreds, hook it. Remember that? All right, so that's for larger numbers. Right? Before you try example 3 on your own, let's take a look at this. What's different about this problem compared to these two that we did? You already know the vibes, right? I see a negative exponent here. So how do you think that's going to change this? Is our leading factor going to get larger or going to get smaller, and by how many place values? That's right, our leading factor in between 1 and 10, scientific notation, to a power of 10. So I'm going to rewrite this right here. And I'm actually going to lose place values because we have a negative exponent. How many place values am I going to go? 1, 2, 3, 4. And my handwriting isn't the neatest, but you got to be careful when you're making these jumps so that you can fill in your zeros here, right? And whenever I have an actual decimal point, I'd like to put my 0 in the ones place just to make it look a little neater. So my answer here is actually going to be 0.000397, right? Tenths, hundredths, 1,000ths, 10,000s, 100,000s. This is 397 millionths, right? That's a tiny, tiny, tiny number, right? Tiny number here. How about number 5 right here? Is this in scientific notation? How can you tell looking at our notes? We have a leading factor between 1 and 10, and we're being multiplied by a power of 10. That's right. See if you can do this on your own before I do it with you, right? This is my leading factor. It's my power of 10 right here. I'm going to write this out, make it look like money. Right? I like to keep my work organized. Since this is a negative exponent, this number is going to get smaller by how many place values? 2. So I'm going to move my decimal place to the left. 1, 2, right? Organize your work here. 0.05. You can add your 2 zeros here if you want to. Doesn't make a difference. It's going to be the same number, right? Now, I want you to try these last 2 on your own, and on the next slide, you'll see my answer key. Try these on your own. Is this number going to get bigger or smaller? Is this number going to get bigger or smaller? And after you do that, you'll check the key, and then we'll do a little bit of vocabulary. I'll check you in the next video.